Mrs. McTaggart here. In this video we're going to look at the part B's to the wave function questions. So we're looking at the part B where it talks about, what's the maximum and minimum value of a graph. So before you watch this, you need to be able to do the wave function. So you should have seen this already. We're just focusing on the part B to a question. So here is a quick reminder. If you're not any good at picturing your sine and cos graph, we can't really go much further with this just yet. So here's your basic sine and cos graph. And I'll always ask my class, right, what is the maximum value of the sine graph? Basic sine graph has a maximum value of 1. Highest number it goes to is 1. So the maximum value equals 1. And I'll say, when does that occur? And that occurs, obviously, here. And that's when x is 90. And then for the minimum value would occur here. It would be -1, and that would occur when x equals to 70. Okay, so that's nice and straightforward. Similarly with the cos graph, it's got a maximum value of 1, but it's got two answers. It's when x is 0 and 360. So 0 and 360. And then its minimum value is here. Its minimum value is -1, and that is when x equals 180. So you might think, oh, quite simple. Obviously, if I then change these numbers, so if I made this a 4 cos graph, so if I changed it to 4 cos x, the maximum would be 4 and the minimum would be -4. If I start moving these graphs around, the maximum and minimums turn out to be different values. So what we do is we have to think of where the maximum and minimum should be, and then that's what we're going to equate our little bracket bit to. So let me show you this. So let's pretend we've already done part A. We've already worked out the wave function part, and we've come out and we've said, right, this is our new equation. So we've done the wave function, and this is what we came out with in part A. I want to know the maximum and minimum value of that graph. Now, if you think about it, this is a 5 cos graph, right? So the highest number would be 5. So the maximum value would be 5. Highest number it goes to. And the minimum value would be -5. Okay? But when does this happen? So let's think of our normal cos graph. So your cos graph, the maximum value should occur at 0 and 360. But -60 means we have moved graph 60 in the positive direction. So we've moved our graph 60 that way. So basically, instead of 0 and 360, we're going to add 60 onto them. But if this confuses you, the easiest way I think to do it is you take your bracket, so x minus 60, and you put that equal to where the maximums should be. So it should have been at 0 and 360. Then you will move that 60 over and make it a plus, and that will give you 60 and 420. Now what I should have said is I was probably only looking for the answers between 0 and 360. So that one would be too big, and I would just score that out and say that's out with. So the answer is x equals 60. So if they ever ask you maximum value, when it occurs, it's 5 when x equals 60. The minimum, I'm going to do the exact same. So the minimum should have been 180, but obviously our graph has moved 60 to the right. So put your bracket equal to 180, where it should have been. Move the 60 over. 180 plus 60 is 240. Alright, so that's all it is, the part B. So what I'm going to do is I'm going to do a past paper question in entirety. So this one is taken from 2018. So you can see up there, part A has wanted you to do the cos expansion of this. So let's go do that. So we'll write out our expression, and we will equate that to the cos formula. So cos alpha, and remember the sign changes, so that becomes a plus, sine. So sine x, sine alpha. So I have got a positive sine alpha, so k sine alpha, k cos alpha. Right, now I'm ready for my wee underlining trick. So sine alpha is with sine, and sine has got a -1 in front of it. Cos alpha is with cos, and cos has got a 2 in front of it. So remember, I work right to left backwards, and I go Sine is with sine. What is with sine? -1. Cos is with cos. What is with cos? It's a 2. Right? Quite simple once you get the hang of it. Then we have k equals the square root of -1 squared plus 2 squared. Remember that minus doesn't really mean anything because it's going to turn positive anyway. So we've really got 1 plus 4, so we have root 5. K is root 5. Your tan alpha equals sine over cos. So we have -1 over 2. Ticky box bit my class hate. Sine negative, so we tick opposites. Cos positive, so we tick all in cos. We can see it's going to be cos, but tan is negative, so we tick opposites, all in cos. Just to clarify, we are working in degrees. So I'm going to go get my acute answer. I'm going to do shift tan of 1/2, which is 26.6. But my wee ticky boxy bit has told me we're going to take that off 360. So alpha is 360 minus 26.6. I need a wee bit more space. And that is 333. So alpha is 333.4. Right, so let's finish the question off. So 2 cos x minus sine x equals root 5. What was my expansion again? I've gone blank. Cos. Cos bracket, and it was a minus expansion. So minus 333 point, oh, I've dropped my 0.4 there. 0.4. Right, so that's me done part 8. Then it says find the minimum value of 6 cos x minus 3. So I have to find the minimum value of 6 cos x minus 3 sine x and the value of x to which that occurs. So I've just written that so that I can take some space. Now, have a look at what they're asking us to find, the maximum of the, I've just gone blank. They're asking us to find the minimum value. So they want the minimum value of this graph, this equation here. Now, look at that compared to the bit above it. Right? What is the difference here? Well, it's that one multiplied by 3. So it's this one multiplied by 3. So the minimum value should have been negative root 5, but we're timesing it by 3. So it's negative 3 root 5. And the minimum value occurs when, for a cos graph, it should be at 180. Obviously, we've got to take in our movement. So it's when your bracket 0.4 equals 180. Now, when you take this over and you add that 333 to the 180, gives you 513, right? Now, that's too big. It's beyond the 360. But please remember, these graphs are continuous, so they will keep going forwards, they will keep going backwards. And the period of the graph is 360. So if I take away 360 from that, that should give me where it happens on the previous wave. So take off the 360. It occurs when x equals 153.4 degrees. And I just made that without running out of space. Right, let's look at one more. So this one was from 2017 and it was in the paper one, so no calculators allowed here. So first part is your wave function, so let's go write it out. So there's what it'll be, and remember we're doing a sine expansion this time, so go to your formula sheet, there's no excuse for copying this down, right? We have a negative, so we've got negative k sine alpha and k cos alpha. So my coloured pen bit. So minus sine alpha is with cos, and cos has got a -1 in front. So you've got a negative and a negative, so this turns positive. So k sine alpha equals +1. Cos alpha, well, cos alpha is here with sine. Sine has a root 3 with it. So we've got that. We'll go to the Pythagoras. So k equals the square root of 1 squared plus root 3 all squared. Well, that's just the square root of 1 plus 3, which is the square root of 4, which is 2. So k is 2. Right, for your tan alpha, we've got sine over cos everything is positive here. So this is your dream scenario. So we've got 1 over root 3. This uses your exact values. The 1 over root 3 comes from your 60, your 60-30 triangle, where this is 2, this is 1, and this is root 3. So to get 1 over root 3, we're looking at the associated angle of 30. And I've just a quick glance up the top, we are working in degrees. So alpha is 30, and see, because everything was positive, all in sine for sine, all in cos for cos, all in tan for tan. So alpha is just 30. So to rewrite my question and finish off part A, we have root 3 sine x minus cos x equals 2 sine bracket, and it was a negative expansion, so x minus 30 degrees. That was a dream question there, other than the negative bit. So that was part A. Then it says, hence or otherwise, sketch the graph with the equation. And watch, they only want us to sketch the graph between 0 and 360. So we have to sketch this now. Right. Oh dear. So, minus 30, what does that mean? Minus 30 means your graph has moved in the positive direction. So this bit here means your sine graph has moved 30 that way. So your normal sine graph would look like this. And instead of starting at 0, it would be here at 30. Instead of the bit being at 180, that would be 210. Instead of the maximum being at 90, that would be 120. The lowest bit should be 270, but that's now going to be 300. And your graph is only to be up to 360. So I'm just going to rub a wee bit out of this so it kind of finishes and stops at what I think the 360 would be. So back to my red pen. So where it finishes, I need to write in that this is 360. So where it stops. And then obviously your graph has to come back to 0, so just carry that back a wee bit to 0. And the maximum and minimum should be root 3 and negative root 3. And that's how I would do the sketch. Think of what your normal sine graph is and shift it all. And definitely, I always draw the shape and then make the numbers match. So I hope that has been helpful. And if this was the same question, they could also ask you for the maximum minimum of it. The maximum minimum bit is easy. It's the shift that you have to think about. All right. So thanks for watching. Bye-bye.